Questions 26 through 28. A wooden square of side length 1 meter is on a horizontal tabletop and is free to rotate about its center of axis. The square is subject to two forces and rotates. Find the net torque of the system. All right, so 26, find the net torque of the system. So net torque. So we have sigma tau. And we have two forces. We have one force, the 8 Newton one is attempting to rotate this counterclockwise, which is a positive direction. We'll call that force A. And this one is attempting to move it in a clockwise direction. This is counterclockwise, right? And this is clockwise direction, which is a negative direction, and we're going to call that force B. So the net torque would be torque A minus torque B. And we know that torque is force A times radius A times sine theta minus force B times radius B times sine theta. Well, if you look at this, if the side is the side is 1 meter, its radius is going to be a half a meter, right? And when we're pushing here, if you extend this vector down like this, you can see that we're pushing perpendicular to the line that connects to the axis of rotation. So the sine is going to be, the angle is going to be 90 degrees. The sine of 90 is 1. So we can eliminate this. And the radius A and radius A equals radius B, which just equals radius, which is 0.5. So we can say that they're both the same radius then. All right, so force A is going to be 8 newtons times 0.5 minus the 4 newtons times 0.5. So half of 8 is 4, and half of 4 is 2. So that equals 4 minus 2, which equals 2 Newton meters. Number 27, where should another 4 Newton force be applied to maximize its torque? Well, we can see that given the answer to 26, that the net torque is going in a positive direction, so counterclockwise, right? So we want to apply another force that's counterclockwise. Well, for A, that's clockwise. That's not good. B is counterclockwise. That's good. Let's hold off on that. C is directed toward the line connecting to the axis. That's not going to help us, as is D. So B would be our best bet. That's going to help us rotate additionally in the counterclockwise direction. Number 28, where should another 4 Newton force be applied to place the block in an equilibrium state? Well, we can see that if we apply a 4 Newton force at a radius away, that's going to give us 2 newtons. So we need to apply a 2 Newton force in a clockwise direction. Right, so a 2 Newton force in a clockwise direction, a 4 Newton force in a clockwise direction is going to give us a 2 Newton force taking us clockwise, which would neutralize the net torque. So A would be our best bet.